Okay, shall I start? Or?
I guess it's not even
I was afraid that everybody would be interested in the future of Haskell. I see at least some of you are interested in the present.
Yeah.
Yeah. So actually, I decided to sort of change the format of my presentation. I think there will be two parts, and just let me know if you are interested more in one aspect or in the other. First, I would like to talk about conduits a little bit more. I mentioned them last time. So, is it okay for you?
Yeah, cool.
Conduits, yeah. Because they are so, for the time being, I'm not going to talk about my application and my web application, but I'm going to talk about conduits. But actually, we will try to solve this issue. I mean, we will try to create, let's say, a ranking conduit. So, I just remind you, conduit is a kind of a pipeline or to process streams of, let's say, data, right? So, we are going to create a conduit which turns just a stream of anything with a kind of a numbered stream, like we are going to assign a consecutive number to each item in the stream. So we are going to create pairs of stuff like in this example. So we have a stream of integers and we turn them into a stream of pairs when the first element is this serial number or the consecutive number given to each item of the stream. The trick is that if you have a series of the same items, you should assign to them the mean ranking, right? So it looks strange, but it's this 3.5 is a kind of a mean ranking for 2, 3, 4, 5, right? Maybe just is it clear? For the time being, right? So we are giving we assign serial numbers, but the problem is that when we have a series of the same identical items, we need to split the ranking between them. So we need to kind of like a arithmetic mean of, right? And then when we have a new item, then we get back to the usual, serial number. So that's the actually why would you need that? I need this for implementing as a kind of a side remark. I need this to implement Mann-Whitney U-test for debugging machine learning stuff. Basically, it would give you the most suspicious features, the most suspicious items in your stream of data. Like, what gives you the largest decrease in your evaluation metric? Like when you're talking about positive and negative emotions, this probably would be a negation, right? It's really tricky for a machine learning model to cover negation when it is trying to guess whether the text is positive or negative, right? Because when you have something like it was not nice, right? The word nice is quite positive, but it is kind of inverted with negation. So I would like to. So I guess that with Mann-Whitney U-test you would get stuff like negation. Okay, but that's just to the point. So let's get back to the conduits. Okay. So I'm going to do a kind of live coding. So if you like, you can follow me. So I'm going to create a completely new project for this. let's call it conduits, I don't know, toy project, whatever. I'm using stack for this, right? So there's a nice feature of stack. You could just create a new project using a number of templates. So this is by default. I think this is just a template for a simple command line application of actually for a simple program. But there are also templates for web applications, like for example using YSOD web framework. Let's start with some simple stuff. So I created this this project. I initiated this project. So we got this. Just basically, this is just hello world for the time being. So just some function which prints some func. So you could, but let us try to compile this and run this. Yeah, it works. So, so if you like, you can follow me. Let us start with. Of course, we need to import basic conduit stuff like data conduit and also data conduit combinators. Right, let me just check them. Okay, so let's start with some simple stuff like this. Yeah, of course you need to import. You need to add conduit library to the configuration file. So let's say here. Oops. So I'm going to do all the stuff in main.hs files. So just I'm going to add this here. Conduit or conduits? Sure. We shall see in a moment whether it works or not. So the conduit project. Conduit project. Stack install. We check whether everything is there. I need to reload. I'm using, by the way, I'm using Intero, which is a nice environment for developing Haskell software. I'm using Emacs, as you can see. I think I need to restart this so that it could see the. So it seems okay. And conduits could work both as a kind of pure functions, like when basically you are just processing some list, right? But also could work within a monad, like IO monad. And so, but we will start with some pure stuff. I think it was run conduit pure. Yeah, light conduit pure. And so we are going to run a conduit without any fancy monad, without IO monad. So we are just going to yield some. So basically, we are going to create a stream using a list, just for this, because usually you wouldn't do stuff like this. You usually you usually stream data from somewhere, from a file or from using HTTP protocol or whatever. But as this is kind of a hello world example, we just create the stream using a list, right? So I just basically give a list of of numbers, and then the operator for, I mentioned this already during my first presentation. It is kind of like, conduits are kind of like pipelines in Linux, in Bash programming. Like, you know. So in just in command line, you could write stuff like, you know, right? Stuff like this, right? And so the operator is kind of the pipe character. So conduits use similar stuff. This is dot pipe. So you're using this to and you need something, and so this is yield many creates a source, but you also need a sink for your data, right? So we will start with something trivial. We just use sink list, which just takes all the data from the stream and puts it into a list and returns this list. So obviously this is kind of, for the time being, this is quite unimpressive, because this is just creating, but we need to extract it to IO monad. So basically you just write something like, let's call it output, and then it would just basically print output, right? Okay. What's wrong here? It's in coordinators and like this. What's wrong here? Okay, much expected time. I'm doing wrong here. Pretty much type. Expected time. I guess it's something wrong.
I think it should be let output equals or
Pardon?
it can maybe let output equals run conduit.
Yeah, it's pure, yeah. Sorry, I'm accustomed. Yeah, I'm accustomed to running in a monad. So yeah. Usually you don't use pure conduits. It's misleading. Okay, great, thanks. Yeah, so for the time being, that's not interesting. It just takes the stream and puts it to the sink. So, but what you can do is stuff like, as for example, you could do stuff like grepping, like right in Linux. Or so let's try to define. Okay, so let's define a conduit which will accept every second item, right? Every second item. So the type will be conduit T. Basically, it could be anything, right? Because we are just taking every second item, so it could be anything. Yeah. And in a moment, I'll define this. So a conduit defines a monad, right? So I'm going to do stuff in a moment. So, but I just explain one thing. Probably I will use the flip chart So the basic type is conduit T, as you can see here, right? Yeah, so it's a kind of a monad transformer, but actually you don't have to think much about this transformer stuff here to understand this. So, but yeah, it takes another monad. So it is a transformer. The third argument is a monad. In a moment I will give the but we have, so the third argument is a monad, right? So it could be an IO monad or some identity monad, which is a special monad for doing pure stuff. Some trivial monad for doing pure stuff. And so a conduit is stuff like, is kind of a, it's like a pipe, right? So so if you have something like, it means that the items of type A go into your conduit, right? And the items of type B, and this pipe is going to produce items of type B. So what about this C? This C is a kind of a, let's say, a byproduct of your pipe, of your conduit. So if it is going, it is used for sinks, right? For sinks. So for the final conduit in your pipeline. Yeah. So it's stuff, and all the stuff is done, and the stuff inside is done in M monad, right? So it's something like this. It used to be in the previous versions of conduits, there were stuff defined like source and sink, but now it's still there, but it's deprecated, right? So I'm just going to use this general monad transformer. Okay, so any questions about this so far? That's not that complicated. So what is available in this monad defined by conduit T monad transformer? Basically, two functions, await and yield. And await, you use await to get some data from the stream, right? So I'm going to, so you write stuff like this, await. Okay, maybe I'll take maybe like this. So I'm going to take every second item. So I just take the first item, but it won't be used later. So that's why I'm using this underscore, this special variable, this underscore, right? And then, but I will be interested in the second value and the fourth and sixth, right? So I'm taking the second item. So let's call it. So actually it's a maybe value, actually, because wait gives you either just if there is something in the stream, right? So okay, let's take it if it's there, and nothing if the stream if there's nothing in the stream, and it's a maybe value. I assume you already know this idea of maybe type. So if there is some item, I'm going to yield this item. I mean to return this to the outside world, to produce this v value as the output of this, let's say, pipe. And if nothing, you could just do nothing. Finish stuff. Okay, so yeah. So what's wrong here? What should I do now? Yeah. I forgot to add to say that M is a monad. So now it's kind of, let's say, okay. At least the type checks. So I'm going to run this. I need to add this here. So I'm going to make my pipeline a little bit more complicated. Less trivial. So I'm going to add this every second as a here, right? So what's something is wrong. That's not what I expected. So what should I? An idea what's wrong here? I mean, conceptually, what should be done here? What should be done here to really have every second, not just the second item, but just every second?
Should be recursion.
Yeah, recursion. So yeah, we should return the value, but we should produce the second value, but we should continue, so you could do the recursion. Yeah. That's right. Now it should be better. Yeah, so now it works okay, right? So, but what if we needed? What if we need stuff like every nth? Right? So let's say we would like to output every third item. So now we want to generalize this. So of course we will need to change the signature a little bit and add, let's say, a new argument and here, the recursion, also we will need the recursion, right, with the right argument. No surprise here. Okay, but for the time being it's still actually every second. So what we should do, what should we do now? How would you do this? How would you generalize this?
Use a weight for n minus 1.
Yeah, so what could you do? What could you use for this?
For n.
For m or replicate m. So it could be, yeah, it's a monad, which means you could use all the stuff from control monad or whatever, right? So how many times? And minus 1, right? Yeah, I think we add this. I think it's defined in control monad, that's why this I remember. There. Yeah. It compiles now, so we can check whether everything's okay. Main, yeah, that's okay. So let's go back to every second. Or maybe just add more numbers here. Yeah, something like just add some numbers. So you could also do stuff like grepping in Linux, right? So you could, for example, you could define a function, let's say threshold. So now we are going to create a conduit which will filter filter out values which are below some threshold value, right? Okay, so so now I'm going to use this, and this is going to be like walnut okay, does it have to be int or no? It can be an a, right? Oh, we shall see. You know what?
Only odd, right?
Yeah, we don't. Yeah, you're right. Yeah. Yeah, you need all yeah. But any stuff which is
we could have predicate actually.
Yeah, you could have a predicate. Yeah, as in kind of a more general. But let's stick to this. So any monad, and it will just give nothing to the outside world. I mean, as this C type. So threshold. We need some threshold value. And again, it will be quite similar, right? So we take some. We are using a way to get a value from. Sorry, my laptop. So we again we use await to get some stuff from the stream, and if there is something in the stream, we just check. Let's say, okay, we just use if. Then what? Then yield value. Note that await returns a maybe, but yield expects just the value, right? It makes sense, right? Then yield the else nothing, and anyway, probably I should use some. Let's keep it simple, and then. Again, we should do the recursion, right? So just like this. Oops. And nothing means you just return. Just go outside. Okay, okay. Well, actually, at least it type checks. So we are going to extend our pipeline with this threshold stuff. So let's say 30. So it will be every third. 3. Okay, so let's try to run this. Yeah, sort of looks okay. Actually there is, it could be done, of course this was just to demonstrate how to do very basic stuff with conduits, but actually you would use, anyway you would use some stuff like from data conduit combinators. There are lots of useful combinators there and for example stuff like filtering. So actually it could be done in a much concise manner with just using the filter stuff. I think it's called like this. Yeah. So of course filter needs a function to filter stuff. So I'm going to use this nice Haskell trick that you could could write stuff like this. Okay, and let me check. Maybe I swap them around so that you can see the alternative, much shorter definition of threshold. So that will be, let's try it. Okay. And let's make sure it's the same as before. Yeah, looks okay. Of course, you could do not just filtering, but mapping. So like you could, I don't know, multiply each number by 2, whatever. So I could just use map from conduit combinators. And again, I'm using this trick of turning a binary operator into a unary function, right? Using parents. So our pipeline is getting longer and longer, and we could do some stuff like mapping, filtering, folding actually, and so on. Right? So let's try. Okay, so let's try to run this. Yeah, so it was multiplied by 2. Yeah, it works. Okay, so let's go back to our issue. So we would like to rank items in our stream. So let's start with some simple ranking. Okay, I'm going to use some new stuff. I'll use this example. It was something like 3, 5, 5, 5, 5, 8, right? And sync list. And of course we are going to put this ranking conduit somewhere in between, right? So let's just check whether it works for the time being. Yeah. So we are going to create the ranking function. So it will be ranking. So again, it will be the type of this conduit T. So we'll take A, and this might be a real number because there are means right there. So it does not have to be an integer. So we are taking some items. We are producing pairs. The first element is the rank, which could be a double, real value, and the second element is the item itself, right? So again, we need some monad, and this is not a sync, so we just give nothing as the third argument, the fourth argument. And so ranking. So how would you do this? I mean, let's assume we are going to use very basic ideas here, no fancy combinators stuff. I would say that you would need. Okay, so let's do this in a not. I guess this is not probably the optimal way to do this, but let's try it. So I'm going to use some helper function, which will have an integer. I mean the starting value for doing the starting ramp, right? So I'm going to define a helper function, which takes which takes double and returns a conduit starting from the given number. Right? So So we are just going to use a weight, right? An argument here. Again, let us check whether there's actually anything there or not. Right, so here we are going to return, to yield the pair, something like this. Oops, yeah, something like this. And if it's nothing, we just stop there. And of course, we need we need recursion. Well, if we stick to this simple, very basic method of doing this. So we need recursion. So what we are going to put here, not R, but R plus, yeah, not exactly, yes, we need something like this. So what's one? 2. This. Yeah, basically, again, I forgot about what. Yeah, I mean, this is so far. This is going to be just the basic ranking function. Just. So what's wrong here? Again, we need a moment here. So for the time being, this is just a very basic ranking function. Right. So let's check what's going on. Whether it's okay. Yeah, we need to put this into our pipeline. So it'll be ranking. Yeah, okay. Looks okay. As I said, for the time being, this is just a simple ranking, but we will need to do something special when you have a series of identical items, right? So what to do with that? Well, we need to make it a little bit more complicated. So basically, we need to remember. We need to compare the current value to the previous value taken from the stream, right? So I think one simple idea would be to introduce some state for your conduit. So it could be something like let's say. Let's call it like this. So it could be just the starting, because we need to consider the special case when it's just the beginning of the stream, right? And also you will need some previous value. If it is not the beginning of the stream, you need to somehow store what was the last value, the previous value, and also actually how many of them were there. So we need. Okay, so we are going to start. Okay, so here will be run state A. And we are going to start from start, right? And here we need the state, right? Okay, so yeah, we need to do something here, right? So we got the value v, and if the value v is basically actually, you could also incorporate this consecutive number within the state, but I won't do this. So there are going to be two separate arguments. So now we are going to check the state, right? So it could be either start. So if it's the start, so the start is easy. You just yield the value, right? And you are going to return. Okay, maybe I just split it into something like this. Maybe it would be easier. So if it's the start of the string, you should let's make it here. And anyway, we are going to call this function recursively, to use this combinator recursively. So we are going to use something like this, right? And now it is going to be the previous value with v. So the next time, we need to remember that the next time we will be having something in the stream. It will be this value v, and it will be just one of them, right? Okay, so far. Okay, so now let's define. Let's cover the case when this is not the start of the stream. So the previous value. So we got some previous value. Let's say u, which occurred, let's say, n times, right? Because the second argument here of the previous value, the second field in this previous value is the number of times the previous value occurred, right? So what should we do now? So we have, what should we now? What should we? The start was easy, and now it's a little bit. It's not so difficult. What should we do now? What do you think? An idea?
Check if it's the same.
Yeah, we should check whether it's the same. It's easy. So if it's the same as here, what we are going to do? If it's the same, so what? Are we going to yield a value or what? What do you think?
Increment ranking.
Yeah, just increment. Actually, probably that's the good question. Whether I just leave this as R. So without, but we'll increment this here, right? So the rank will be the same, but it could be done in a different way. Let's assume this. And if it is not the same, if it is not the same, what should we do if it's not the same? We should yield, but which value? The previous value, right? So now it's getting kind of. So definitely we are going to yield. Oops, I think this is should be. So it's we definitely need to yield the previous value. And actually just yield or what?
We should yield n times, I think.
Pardon?
We should yield n times.
Yeah. So we could use this replicate. Yeah. So we should replicate this yielding n times. And yeah, I guess. And we should yield, but with which value? And now it's a little bit tricky just to guess. I think it's not complicated math, but just help me. And yes, it should be R plus what? It should be stuff like. Okay, just let for the time being let's just use R, and we will fix it later. It will be easier, I guess, than just guessing here in the middle of the stuff. So it would be R, and then you are going to use this recursively with R and what? Actually, it should be R plus and I guess, and we should do, and now the previous, we're going to have a new previous value, something like this. And we will need stuff like, just probably might be the same, but I'm not sure, so I just, okay, so what's wrong here? We need some stuff like this. Let's say. So what's going on? Yeah, and how to make double, how to take, how to turn an integer into a double
from integral.
From integral, right? So something like this. What's going on here? Yeah, what is missing here? Actually, we don't need ordinal, we don't need ord here, but equality is needed, right? Because we. By the way, we assume here that the string is sorted, so we don't need ord here, just equality, right? So A should have equality operator. The equal sign should be defined for A. Yeah. What's wrong here? I mean, let's try to. It's not finished, but let's try to run this. Why it's still telling me? Rankings also should be defined for this. Right. So is it okay? Yeah. So what are the issues here? What should be fixed? What should be fixed? One, of course, is that we need the mean of the values, not the. Actually, yeah, something is wrong here. At the beginning, something is wrong, I guess. At the end is missing. So let's start. I think the easiest part is to fixing the end. So you need to do, when it's nothing, actually you need to do something. You should have a little you should take the previous value. Unless it's an empty stream, might be, right? So we need to check whether it's empty. If it's empty, we just do nothing. But if it is, if there was some previous value, we are going to. Okay, yeah. If there was something, we should replicate again the stuff with again with where's the application? Yield R and U. Right, and not U, but V. What's wrong? I replicate, it's stupid and doesn't know. Okay, let's say. Yeah, it's probably not the the best Haskell I wrote in my life, but let's make it like this. So let's try whether it fixed anything. Yeah, at least we have the final value, but with the wrong rank. Yeah, okay. So what's wrong with this? Why we have this twice? Yeah, why 3 was twice? Idea. Yeah, because actually this was not needed. That was simple to fix. So let's try run this again. Oops. Yeah, it looks a little bit better, but it still starts from 2. So let's fix this. This should be minor stuff to fix. Just put it here. Yeah. So now the tricky part with this mean. Actually, I think not pretty tricky. You just need to do this stuff here, right? So it should be what? It should be not R, but what? Let us just define some helper variable. Double. So it should be like as double, I guess, divided by 2. Maybe. Let's have a look. Yes, it should be replicate. What's going on? Okay, so it's nearly perfect. I mean, it should be 3 point. I think you should add 1, basically. Get it right. Okay. So this and this. Okay, so it's okay. Actually, you would need also to fix here, right? So it's not done yet. Probably you will need to refactor the code so that it is not repeated. But let's stop here. So it seems kind of okay. Of course, actually, it's probably you would use fault for this rather than it's kind of very simple way. I mean, simple, basic, crude way of writing this. There is some nice. When you have a look at combinators in here, you will find some. But just actually, it's not just fault, but it will be, to be precise, it's fault E. No, fault E. It's called. It's fault group, right? With fault, because just fault is for combining monoid values. If you have some special function, your own function to combine, to do the folding, you need fold. So that's so probably you should use fold. That will be simpler and I guess more better. So that's the idea, but actually speaking and going back to my application, you might imagine that I'm using conduits for processing my data, right? In machine learning, you actually very often the data is quite simple, like just a number of columns, number of variables, usually without any hierarchy of data, something like this. So the data is simple. The problem is that usually you have, hopefully you've got big data, right? So that you could train a nice machine learning model. So if you're going to process streams of really big data, large data at least, you need a solution like this. You need conduits. There are some alternatives to conduits like pipes. You would need conduits because you might ask, why not use simply here you could use just lists and foldable and maps and maps and filters and just use lists. Why do we need conduits? Actually, conduits gives you some guarantees. I mean, your memory will not explode due to some space leaks. And if you use some basic stuff like maps and filters and lists, well, in many cases, the compiler does fusion, and so actually there won't be any space leaks. But there is no guarantee, right? It might depend on some settings and so on. So if you are really going to do stuff like processing large streams of data, you should use conduits or some alternative library. And also conduits give you some more stuff like there's always the problem with resources like file handles, right? And the conduits library helps you just, you don't have to remember about this basically, in many cases. And another point is, yeah, it looks like this notation is really nice, very concise. It is similar to the pipeline notation from Linux, and it's really cool, and you could create a lot of nice pipelines. Of course, usually you won't run pipeline conduits on this. Usually, I think I have some. I'm going to do this live. I think I had some already made stuff, ready-made stuff, which is I guess here. I'm going to show you how to do the actual graphing on a standard input and output the stuff on the. I think it's here. Let me check. Yeah. So actually, you could implement grep with conduits, right? And of course, now we are going to really to run it within IO monad, not just pure stuff. So now I'm using run conduit res function, and it really starts looking like a Linux pipeline, right? You just take standard input, decode it into UTF-8, assuming it's 8 UTF-8, split it into lines, right? And then you basically use a filter function provided by conduit combinators library, and you just check whether some string is there in each line, and then you do unlines. Unlines is basically adding a new line character at the end of lines, and you just encode the stuff back to UTF-8 and put it into standard output. That's really cool. You could just do stuff like you do in command line in Bash. And I'm using this in my application to handle this. As I said during my first presentation, I just take two streams of data, right? One stream with the actual output and the other one with expected output. I'm kind of zipping the streams. For each pair, I calculate the loss value, the loss function, and then I'm aggregating all the stuff using like average mean or whatever I want, and then I'm outputting the stuff to the outside world, to the I/O monad, and I'm basically printing the value, the final value, right? So it's really cool, very useful stuff. So I'm just going to. So that is the first part, and the second part will be quite short. I'm just going to give you a very short overview of these, how I develop my web application. So the web application is.
Excuse me?
Yeah.
Can you have a break?
Yeah, I guess, yeah. I just assumed that, okay, we have a break. I promise the second part will be very brief. Actually, we should finish at 5 o'clock as far as I know, so it should be
5:30. So.
5:30 as far as I know, it's okay. Okay, so let's make a break and we will continue. Okay, so I assume I can get back to my presentation, to the second part. So I'm going to give you a short overview of the how I developing my my web application. The web application is this. This is for keeping track of machine learning. This is kind of like, this is a platform for machine learning competitions, let's say. Actually, it's this competition aspect does not need to be emphasized. It's also about, so it's not only competition, but also actually cooperation and basically keeping track, even if it is just one person. If you are working with machine learning models, it's actually quite easy to lose track of what you did, or what is your best, the top value you achieved, and so on. So it's, even if you work alone, it's quite useful to have a simple place to store the. So let's, for example, as part of this challenge about guessing the gender, actually the grammatical gender of the erased from Polish texts. So for the time being, the best result is nearly 70%, but you could see other results. I'm using this for a variety of purposes. I'm using it for my research, but also for teaching machine learning and NLP classes, right? So this is also used by my students. They have some assignments. They need to create logistic regression model, naive Bayes model, neural network, whatever, and they submitting the stuff here. So I can. So actually, there is also, apart from machine learning stuff, there is some stuff related to keeping track of scores and what a given student is working on, and so on and so on. So, but it's just a place to store the evaluation results, right? And actually it's good that the previous presentation by Chris was also on, in a way, was also on web development, right? Using Haskell tools, and I'm using a different approach and a different framework. And I think the reason is that it's a little. This web application is probably a little bit more complicated than the application Chris presented in the previous presentation. One issue. Well, it's not a really huge application, right? It's not a. And I must say that I'm not a top, web developer or something. I just needed to develop a web application, a simple web application quickly using Haskell, right? So where's the complicated stuff? I think one stuff is that the database scheme is quite complicated. There's a number of tables there. So let me have a look. Well, I should start with what I'm using here is I'm using ESOT framework, right? So it's not Scotty framework, but ESOT web framework. It's a kind of a fully fledged web framework. At least as far as templates and database connection is concerned. So the name is ESOT. I guess, yeah. So that's this. And what is cool about ESOT is that a lot of stuff is type checked, right? Actually, I write kind of I use this flip chart. So in ESOT web framework, stuff like DB database, right? Templates and your I mean HTML, for example, HTML templates, and the logic of your application, I mean Haskell code. This is tightly coupled and type checked, right? So if you make a stupid mistake, if you make a stupid mistake, your web application simply won't compile, right? Because there will be mismatch between types. And I will show you how this is done within ESOT framework. So let's start with database. So the database is, there's a special kind of domain-specific language, very simple language for defining a database scheme. And it looks like this. So this is not Haskell. I mean, actually template Haskell is used here to read this stuff and combine this stuff with Haskell code. But this is a kind of very simple language, and you just define tables and their fields. Also, you could define some keys and your tables and so on. So yeah, as you can see, that the structure of the database is quite obviously not the most complicated in the world, but it's not just 2-3 tables. There are more of them. And so and on the one hand, this is turned into SQL assuming I'm using Postgres SQL, so it is turned into a Postgres SQL scheme, and on the other hand, this is turned into Haskell code, right? So not only a table user is defined in Postgres, but also user is available as a type in Haskell, right? And this makes this is really powerful because if there's some stupid mistake, you forgot to do something, usually this is detected by the compiler. I mean, the compiler simply won't compile your code, right? As I said, this is based on template Haskell, and some people dislike template Haskell for some for reasons, and actually they have the reasons are reasonable, let's say. But I think the advantages for me are better than disadvantages. So that's the database, and how to use the database. You could either use persistent library, which is maybe not a part of which is tightly coupled with ESOT. I mean, ESOT, probably you could use ESOT without a persistent library, but probably that would be the best idea. So let's have a look at some code, Haskell code, whatever. I have some message board for discussions there. So yeah, for example. So when somebody is writing a comment on my website, you basically need to do an insert, right? So so there's just a function which is called insert, which is provided by persistent library for doing DB stuff, and you basically add a comment here, right? So this time this is Haskell code, so comment is a Haskell type basically. But the nice thing is that if you do something, something here and forget about the database, it will break, and you will see the problem. So let's make an experiment like this. So by the way, now I'm going to start this web application locally on my laptop. Actually, there's a nice tool for running your application when you are developing it, right? That's quite, I guess, the usual stuff for web application, for web frameworks, for other programming languages as well, but it's quite nice. So if you write something like this, it will start the application, right? And I guess in a moment it should start. Yeah, it's there. So because now I can just go to the local IP address and see the application running, right? But if I changed the model, like let me add some field, whatever. Let's say some Boolean value, whether it's spam, whether it was marked by somebody's spam or not spam, right? So when I add this here, I think it's Boolean. So I have a table with comments, and I just added a field for keeping the information whether it was checked for being a spam or not, and if it is checked whether it was marked by some, let's say, moderator or somebody as spam or not, right? So if I save, so I'm saving the file, and then what's going on? The model is recompiled, right? Kind of a wrapper around this stuff. So you're going to see a lot of warnings and hopefully an error, because there is something wrong here, right? Yeah, so it's, as you can see, this YSOT tool, it automatically started to rebuild all this stuff, right? So whenever I'm changing anything in the source codes, including the model, the scheme, something is wrong, right? Couldn't match type, persist entity backend with maybe bool comments. So yeah, basically because I forgot to, I would need to do something here, right? So probably I would need to do nothing, to add nothing here. Of course, it actually defines a record, right? So and a more better way would be to use a record rather than just this simple syntax, but that's not the point. So again, it started to recompile the stuff, and maybe these are warnings. So we're just rebuilding the stuff, and we will see what happens.
Czekam aż się skończą, bo na plecach nie chcę sobie przytrzymałem się.
So it's rebuilding, and maybe in the meantime I will show you. Yeah, actually. Yeah, there was one interesting thing, yeah. So automatically, of course, the Postgres scheme was updated as well, right? You can see this here, right? That the command table was altered, and so it's really cool feature. What about templates? I was talking also about templates, and templates are also, there's a special library for templates. These are so-called Shakespearean templates because, well, as you can see, they use some funny names like Hamlet, Julius, and I think there was also some Shakespearean name for CSS templates. So let's have a look at the template. There is a special language for templates, right? So it's a kind of a HTML, but with where intended, right? So the number of spaces, the spaces are meaningful here.
Yes.
What is important here is that, well, basically these are templates like in many web frameworks and many programming languages, but again the types are checked. So for example, you have a link here, right? You define a link to some other part of this website, and basically it has to type check, right? It must be correct. Right? If something is wrong here, then your program won't compile, right? So it's really useful and makes your life easier as far as creating web applications. So I would say that for medium-sized web applications, YSOT is really a good solution, right? So stuff like this. As you probably noticed, I'm not a user interface guy, so this is really kind of crude, the user interface here. There is not much JavaScript stuff here, and so most stuff is done in the old school way, right? Just posting and getting and so on. And actually, what is missing in eSalt would be some really nice integration with user interface stuff, with some JavaScript or PureScript or whatever stuff. I think theoretically there is some, but it was not so cool as this database and template stuff. Right? I don't know. Maybe you could. Maybe you have a good answer to this. Maybe there's some other fancy web framework which combines this cool idea of type checking with modern user interface stuff like reactive programming and so on. Any ideas? Do you have any? I think it would be really nice because for doing medium-sized, old school web applications, that's really perfect. For me, eSalt is really perfect. I'm not a web developer, so it is really relatively, for me, it's relatively easy to do this stuff, even though I'm not I don't know much about web development. So it's okay. But what is really missing is the part about some cool UI stuff with reactive programming and such stuff. This is missing. This is not there in eSalt. Or I assume you could combine. Of course, you could use JavaScript here. You could combine. Actually, I have some JavaScript, but it's still not that nice as on the stuff. Database is really fun, and just the final stuff. So for database, you could use either persistent, which is okay for basic database stuff like inserting, doing simple updates, getting simple information from a database. But when you are going to do some more complicated stuff like joining tables, the good news is that you don't have to write. You don't have to go back to SQL. Just you could use. There is a very nice library which is called Esqueleto. The idea is that to write SQL-like expressions using Haskell. So this is not template Haskell. This is just Haskell. I give you some example. Sometimes I need to do more complicated stuff here with database, like joining. So, sorry, it is the screen is too narrow, so it's kind of not as readable as it is on a large and wide screen. But basically, you use so this Esqueleto library. The name is. So it's database.esqueleto here, right? Whenever you need more complicated SQL stuff like joining tables, you could use this Esqueleto, and this is really because it actually it looks like SQL, but it is Haskell, right? So you got select, from, where, order by, right? I think that this e dot is kind of stupid, and if without this, it will be even more readable. So you could do joins and stuff like this. So all the things you would do in SQL, like for example PostgreSQL, you could do just for using Haskell. And of course, I think it's really a good idea, and it's powerful and very useful tool if you are doing some database stuff. I really recommend using this rather than I think one limitation is that I think it's only for Postgres. I'm not sure. Persistent is also this persistent, more basic library, which is used in the salt. Persistent is could be also used for some no SQL stuff like Mongo or MongoDB or whatever. But Esqueleto is well, that's quite no surprise because it's about emulating SQL. So it's for backends like Postgres and maybe some other SQL engines. No idea. Okay, so so I would really recommend if you are going to set up medium sized web application, eSalt might be a good solution for you. Okay, I guess that's. Do you have any questions? So if not, and by the way, just if you're going, when I was starting my project, my Gonito.net project, what I was missing was an example of a real eSalt application. I mean, not some just Hello World toy stuff, but real application. So if you want to do your own web application, I think mine would be kind of a good place to have a look, right? So because there's really this is not a toy application, so you could have a look there to have some ideas, or maybe to avoid some bad ideas. Okay, so I think that's all from me for today. Thank you for attending. Thank you.